Welcome all of you. So in this video we are going to take up the very first type of numericals of electricity. Okay, so this is based on charge and current. How many electrons are there? How many? What is the charge per electron? Sums based on this. So if you have found these sums difficult till now, go through the entire video because I am going to take quite a few sums based on this. Okay, so let us start. Now here in a conductor there are 6.25 into 10 to the power 16 electrons, that is conductor is a wire. Okay, this is question number 1 from Selena. This is 6.25 into 10 to the power 16 electrons. Now in these sums we have to be very careful. Are they talking about electrons or are they talking about charge? Don't take one for the other. So here 6.25 into 10 to the power electrons, 16 electrons are flowing from point A to point B. Find the current flowing through the conductor when the charge in each electron is also given to you. Generally it will be given. Okay, so here this is 6.25 into 10 to the power 16 electrons. Okay, now we have to understand that each electron carries this charge. So what is the total charge that it is carrying, and what is the formula we have? I is equal to Q by T, right? When Q is in coulomb, T is in seconds, right? Q is in coulomb, T is in seconds, I comes in amperes. So now if I want to find what is the total charge in coulomb, then it is 6.25 into 10 to the power 16 into the charge that is carried by each electron. This is number of electrons. Charge carried by each electron is here 10 to the power minus 19 by 2 seconds. In 2 seconds this is happening. Okay, so in 2 seconds how will I put it? Here I just have to put a 2 because it is already in seconds. Okay, so here this, now we'll have to multiply this and see how much it is. 6.25 into 1.6. okay, so that is 3, 5 and 37. 6 to 5, this is how much? This is 10. That comes to a 10. If I multiply this number with this number, it comes to a 10. Okay. Now look at the points. This is 10 to the power minus 3. Okay. This with this. So 16 minus 19, that is 10 to the power minus 3 by 2, which is 5 into 10 to the power minus 3, which is 5 milliamperes. Now what is the direction it is flowing from? Now remember one thing, if charges are flowing from this, electrons are flowing from A to B, then you have to say current is flowing from B to A. Current flows in the opposite direction of the charge. So this is my answer. Find the current flowing, it is 5 milliamperes. Now here is the second question in which they are saying a current 3.2 milliamperes is flowing through a conductor. Let the conductor be A and B. Current is 3.2 milliamperes, they have told us. Okay, is flowing through the conductor, and if the charge on each electron is a minus 1.6 into 10 to the power minus 19, that they have given us. Okay, then coulomb, find the number of electrons that will pass each second through the cross section of the conductor. This many coulomb is the charge on one electron, and this much current is flowing. How many electrons? Find the number of electrons that will pass every second. Okay, what we have to find? Number of electrons passing in 1 second. Okay, through the cross section of the conductor. Through the cross section is nothing. That is how it is defined. Okay, that is how current is defined. That how much charge is passing through the conductor, through the cross section of the conductor in 1 second. So number of electrons in 1 second. So here we have, let me use this formula. Current is equal to Q by T, charge by time. Okay, now charge is number of electrons into charge in one electron. I'll put a minus here, into 10 to the power minus 19. Okay, so that is the charge is this number of electrons into charge in each electron. By the time here is this was the current 3.2 milliamperes. Okay, so that means this much coulomb is passing in 1 second. So we should take 1 only here. Okay, and then what is the value? Now here what I have written is milliamperes. Okay, so if I have to convert it to amperes, then I have to divide it by a 1000. Okay, then I'll get it in amperes. So here I'll just find the value of n. This is 1.6 3.2 by 1000, okay, into 1.6 into 10 to the power minus 19, which is 3.2 by 1.6 is clearly a 2. Then this is 10 to the power minus 16, which is 10 to the power 16. This many number of electrons are flowing through the conductor per second. We don't put a unit here, no unit, because it is nothing but the number of electrons. Okay, so next sum. Find the potential difference required to flow a current of 300 milliamperes in a wire of resistance 20 ohms. Okay, so here this is the third question. Now V is equal to IR. Okay, if they are talking about potential difference, we'll put the 20 here. Okay, and they want the potential difference. And now here I'll put a 300, but it is milliamperes, so I will have to put the 1000 here, okay, to convert it to amperes, because V is equal to IR. When this is in ohms, this is in volts, then this value of I should be only in amperes and not milliamperes. Okay, so that gives me a 6, and cut the zeros, 6 volts. Okay, you can write only V as well. So that was a straight V is equal to IR type of question. An electric bulb draws 1.2 amperes current at 6 volts. Find the resistance of the filament of the bulb while glowing. Now, the moment you see this question, you should write 1.2 amperes, and then volts is 6 volts, and resistance while glowing. Now resistance of the bulb while glowing, that is R, is how much they have asked. This is a clearly V is equal to IR type of question. 6, 1.2 and R is clearly this, which is 5 ohms. Okay. A car bulb, this is the fifth question. A car bulb connected to a 12 volts battery. So voltage is 12 and current is 2, and then we have to find V is equal to IR. So we have to find the resistance. Resistance is 6 volts. Now what they tell, there's one other part of the question. Will R be more or less when the bulb is not glowing? Okay, so when the bulb is not glowing, the R will be less. Now why will it be less? Okay, R will be less because resistance is directly proportional to temperature. Okay, more the temperature. So when the bulb glows, the temperature increases and the resistance also increases. When the bulb is switched off, then the temperature reduces because the filament is no longer hot, and the resistance also decreases. So the resistance of the filament of the bulb is little bit higher when it is glowing. What is the filament of the bulb? This is a bulb. You see that thin wire, okay, very thin wire. Bulb is like this, okay, and you see a very thin wire over here. That's the filament. Now this is a very simple question. Calculate the current flowing through a wire of resistance 5 ohms. V is equal to IR. Resistance 5. Okay, in place of resistance I wrote a 5, and battery is connected to a battery. Here is 3 volts. You have to find the current. So current is 3 by 5, which is 0.6 amperes. So that was it in this video from V is equal to IR type of questions, very simple ones, and questions based on charge. Okay, so the questions that were based on Q by T is equal to I. Okay, so we'll stop here today, and in the next video I am going to take up specific resistance questions. Now specific resistance is something we tend to neglect, so please go through the video. Many questions are asked from that. So specific resistance in the next video. If you have liked the video, do not forget to like, share and subscribe. Okay, please share the video with your friends, and also leave a comment behind, because I would love to hear from you how well you all are understanding. I would love to know. Okay then, thanks for watching the video. Bye then.